Hello everybody, welcome to MySQL QA episode number 8. In this episode we'll have a look into reducing test cases at a more advanced level. We'll tune reducer.sh further from where we left off in episode 7. If you haven't seen episode 7, which was all about the basics about reducer, but it still went on for an hour and a half into some more lightly complex stuff, I would suggest going and have a look at that, especially if you haven't had much experience with reducer yet. Then this episode will be too advanced to follow from the outset. You probably can skip ahead from episode 7 and straight away jump into this one. So if you haven't had a look at 7 yet, or if you haven't had a fair bit of experience already with reducer, go and have a look at episode 7 and that will get you started. If the content goes a little bit too slow for you, maybe just consider speeding up YouTube to 1.25 setting. It's there at the bottom of the screen, and you can do that for episode 7 just in case you want to cut that hour and a half into 25% or thereabouts less. Okay, so let's get started with some more advanced options for reducer. So first we'll have a look into force skip-v and force sporadic. So you remember from the last episode, if you haven't got Ranchen yet, where reducer lives for historical reasons, just go ahead and branch it, and then you can find reducer in the util reducer directory. Okay, so we've looked into all of these options the last episode, and now we'll have a look into force skip-v and force sporadic. As it says here at the top, and remember at the bottom you have more information about each of the options. You will be able to find a lot more interesting information to go through there, even more than what I'm giving you today in these episodes. So if you need help, go and have a look there. But as it says here at the top, these are for sporadic test cases. So they're used when test cases prove to be sporadic and fail to reduce using basic methods. So if you remember, when reducer starts up, it runs a verify stage in which it uses 10 threads to see if a particular issue is sporadic or not. And if all the 10 threads reproduce the issue, well, clearly it's not sporadic, so it continues in single thread mode, which takes less system resources and still goes quite fast. If it does prove sporadic, it will stay in 10 threads, or however many it got up to by that stage, up to 50 according to the default settings. And then it will leave all of those threads running, and as soon as a simplified version of a test case is found in any of the threads, it will shut down all threads, grab that particular reduced test case, and start reducing it further again in all the threads. Now, if you know that an issue is sporadic from the outset, then you can turn these options on. And actually, if you turn skip-v on, it will automatically enable for sporadic. But if you want to be very detailed, you can go and set them both to on. And what happens here is, in terms of the first option, for skip-v, that actually means force reducer to skip the verify stage. So in other words, it's not going to do a verify stage. And when force sporadic is on, the reducer is automatically going to assume that the issue is sporadic. So in effective terms, what this means is, let's say you have a test case. There's your test case, and of course that test case has a few thousand lines of SQL. And when you start reducer without any of those options enabled, so they're both 0, then it will take this test case and it will execute that through the verify stage 10 threads at the same time, so 10 times the full test case. Then from there it will conclude, okay, I saw so many crashes, and if it were 10 crashes, then my issue is not sporadic, and so on, just like we saw in the last episode and just before. However, you can tell reducer to basically just skip this and say, okay, the issue is automatically sporadic, just assume it's sporadic, and straight away go and reduce this issue with 10 threads at the same time. So this could actually speed up normal test case simplification as well. If you turn on here and here. If you turn this on, then straight away the verify stage will be skipped and the sporadic will be turned on, so it will use 10 threads straight away to start reducing the issue. So even if it's not sporadic, it will still go faster because now you got 10 threads trying to simplify it. As soon as one of the threads finds the particular issue, it will shut down all the threads, grab that particular simplified version of the test case, and it will start all threads up again, and all 10 threads will use that simplified version, try and simplify it further, and so on and so on. So it's sort of like a reducer on steroids. It will go a lot faster. Why is this handy for sporadic issues then? Well, if we go through these initial verify stage and the 10 threads all fail to reproduce the issue in the first run, and remember this happens 6 times in a row, right? Each time with less and less initial simplification. So at some point it goes to the lowest level of initial simplification, which is basically no simplification, and it will run that against all 10 threads. So by that time we've got something like 60 executions of the test case, and the last execution is fully without any simplification, and we still don't see the issue. Well, then reducer will go one step further and it will start 15 threads and 20 and then 25 and then 30 and so on to all the way up to 50. So by that time there's hundreds, if not over 1,000 times that the test case has been tested. So if by that stage it still hasn't reproduced, the issue is very highly sporadic, or simply the test case is not able to reproduce the issue that you're looking for. Now, if we know that the pQuery framework, pQuery binary, has found a specific issue, and we can see that it's likely going to be sporadic, or we've tested it and it goes up to 10, but then it says the issue was not found, so I'm swapping to 15 and then to 20, and you're trying to save system resources, then you might just as well turn these on to 1, because if you turn these on to 1, it will stay with those initial 10 threads and it will not start going to 15 and 20 and whatever. It will just keep hammering on those 10 threads each time with a different version of the simplified test case. So in a way it's on steroids when you use it for issues that are not necessarily sporadic and that you just want to reduce very quickly. Or on the other hand, if you want to save system resources and you don't want reducer to go all the way up to using 50 threads, which is very resource intensive, then because by that stage you're running 50 MySQL Ds with 50 clients against it, just all sending through SQL, even if single threaded, that's still quite a bit of items going through there. And so you can tell it, hey, just go straight away, skip your verify stage, don't worry about that, assume straight away that it's sporadic, and so then reducer is nicely going to stay in the initial number of threads that it's configured for, and by default that's 10. And that brings me straight away to these expert options here as well. So unless you fully understand what you're doing, don't go and change it, but now that you're learning, you can go and change it. So by default, this is 10, and that means X, 10 MySQL D servers plus 1 MySQL or pQuery client each, and of course those can have a different number of threads as well. But let's assume for the moment we're not looking into multi-threaded reducer yet. That's for the coming episode. So when I say, just for clarification, multi-threaded, that's what we'll look at in the next episode, that's effective multi-threaded, so where multiple clients are hitting the server. Here we are talking about multiple threads of simplification, which is very different, right? Here we're talking about 10 threads that are trying to simplify a particular issue. So just to give you a little drawing, here's your MySQL server, here's your client thread connecting to it, and so we say with this option here, multi-threads, I want this 10 times, right? So, but remember, you could have multiple clients, right? And that is what pQuery multi is all about, multi-threaded simplification, where you effectively have multiple clients connecting to a MySQL server, and that's the number of client threads in that case. So we'll get to that in the next episode. For the moment, here we're focusing on the number of reducer threads that is being used. So if we set for sporadic is 1, then initially it will use 10. if both of these options were 0, this option would still be used because it would now do the verify stage, and the verify stage in the original startup uses multi-threads as well. It uses 10 threads for verification. So this variable works as well for the verify stage as for the established sporadic stage. Now, you know how I said it goes from 10 to 15 and then to 20? Well, that's simply the MySQL threads increase. So if you start it up with both of these 0, it will do the verify stage, it will use 10 to start, then go to 15, then to 20, and so on, and up to 50. I think that the 50 is a hard-coded value. So, in other words, 10, 5, 10 plus 5, 15, 20, 25, and so on for the verify stage. Or if we skip verify, which automatically turns on sporadic, then it will use this, but not this. So it will never go and increase it. It will simply use the number of original threads. So if you have, let's say, 20 or 30 issues that you have to simplify and you're trying to figure out how you're going to do this on your i7 server, then you probably, well, one idea might be that you either start them gradually, and you start a number of reducer processes, you let it do the verification stage, and if the issue does not prove sporadic, then you can simply let it go and it will go to one thread, because this is only valid as long as the verify stage lasts, unless it finds that it's sporadic or unless it's told effectively that it's sporadic. And then it will swap to one thread, and great, so then you can start a few more and a few more. But of course that takes time, and you need to watch it for a little while and handhold it a bit. And if any of them start running away to 20, 30, 40, 50 threads, then you might get into a resources issue. So what about if you set, for instance, multithreads to 5, and you skip the verify stage and you force sporadic, and you figure out, okay, if I have 5 threads, then I can maybe start 15 reducers or 20 reducers, and that will not kill my machine. After a while, you approximately know how much machine can carry or not. And when you do that, then you have all these threads effectively using whatever you set for multithreads. In this case, we set 5, and it will, or 4, for example, and it will reduce all these issues, sporadic or not, as if they were sporadic, and it will use 4 threads constantly for trying to find better test cases. And so you can start that and walk away from it, right? Because it's never going to increase because you've told it from the outside, use sporadic, and it's just going to use the number of threads programmed. So why do we not always do this? Well, some issues are sporadic and you start them, and they need, for instance, 20 threads to figure it, to find the issue, because it's very sporadic. That happens, you know, even sometimes 30 threads or something like that. So when that happens is you could just leave your machine busy with those 30 threads for simplifying that particular issue that you're seeing, just because it's so highly sporadic. It's better to run 30 threads just for one issue. If you were to put it to a lower number, those 4 threads or 5 threads or whatever you set it to would take a long time to come up with a short test case. So again, all these options, you would only really start playing with them in 2 cases. The first case is you've tried to run the standard reducer with these options set to 0, and you find that the issue is sporadic and your number of threads starts going up, and you want to stop it straight away and say, hey, my machine is already very busy. I'm just going to set it to sporadic. I'm just going to set it to skip verify stage, and it's going to run for a while just with the number of multi-threads that I set it to. And I'll come back in half an hour or an hour. If it still hasn't reproduced the issue, I'll try something else. So that happens a fair bit. The other reason is you have a lot of test cases that you have to simplify, and you want it all to go as fast as possible. You want to load your machine to the absolute max, but you don't want to have any sort of reducer start to use 20 or 30 or 40 threads. So you force it in a way to just use whatever number of threads you give it from the outset. Okay, great. I think that covers force skip fees, for sporadic, multithreads, and multithreads increase. So we already briefly touched, and I'll come back on timeout in a minute. We already briefly touched on query timeout and stage 1 lines. So very quick rehash. A query timeout is the timeout for particular queries. It's not really so necessary anymore with pQuery these days, because our pQuery runs take 15 seconds each by default, so we would never really reach this. But in RQG days it was quite important, because RQG killed queries after 60 seconds by default if you had set one of our default grammars. However, in a reducer you wanted to make it a bit larger, about 1.5 times as much, so that's where the 90 came from. So in general I would say, if you use pQuery like we do, just ignore the query timeout. If you do use longer runs, like where you run pQuery for an hour, you might want to set this to a very high number, just so that your queries are not getting killed off, because if they're getting killed off, you might have a different way that your test case was executed, right? It's no longer the same as when it was executed with pQuery. This also, I think this uses the MySQL clients. If you use pQuery, it might by default not be able to connect. I'm not sure. In any case, it's not really used very much at the moment anymore. Stage 1 lines. So this is quite important. When it has 90 lines left, it will go to stage 2, and stage 2 is different from stage 1 in that it will no longer grab random chunks from the file trying to eliminate them, but instead it will now start line by line trying to eliminate each line individually. So usually you just want to leave this to 90. That's just a value that's based on experience. But if you have a test case which for some reason just doesn't seem to be getting past 110 lines, then of course you might want to increase this to 111, and then it would jump into stage 2 and start trying to reduce line by line. I haven't run into that problem very much anymore since we came to a nice balance of 90. Okay, so skip stage is another variable that we have a quick look at here. So usually you would never change this, but you can change it to skip one or more stages in the program. Let's say that reducer has gone all the way up to stage 5 and you don't want it to go through the initial stages and trying to do verifying and trying to do cleanup of lines and whatever. You could just simply enter a skip stage here, and it will just jump ahead straight away to the stage that you had in mind for it. Okay, so I assume that the setting would be based on the effective number. So if you want stage 4, then you probably have to set skip stage of 3 so that it starts with number 4. For skill, it's a slightly interesting option. I never use it myself, but it's there if you want to use it. So instead of trying to do a proper MySQL admin shutdown, you can force a kill. That will only work in certain cases. For instance, if you're trying to deal with shutdown issues and you would set this, I think it would create a mess. But it might be interesting if you got a lot of test cases and you really want to push everything you can out of test case reduction. You could turn this off on, and it will no longer try and do a proper MySQL admin shutdown. Now, there's a little tip here, and that is some issues only show on shutdown, and that's why we try and do a proper MySQL admin shutdown. If you know that an issue doesn't trigger on shutdown, you might turn this on just to get a little bit more speed, but in my opinion you probably want to leave it off and just ignore it altogether. Okay, so we'll jump into timeout command and timeout check now. So it's slightly tricky to understand because they somehow seem related, but they're actually very separate. They're in a way quite distinct from each other. They're completely distinct from each other. Okay, so let's consider them as distinct items. So first of all, we have the timeout command, and what this allows us to do is set a specific timeout command, but then still use mode 2 or 3, for example, and check for a particular string. So let's say that we set timeout command to timeout, signal sig kill 10m, which means 10 minutes. Then MySQL D will be terminated after 10 minutes, and then a check for whatever text was set according to whatever mode that we're looking for will still be executed. So we would never use timeout command in combination with mode 0, and mode 0 is specifically for hangs. So let me explain this. This command, timeout check, is used in combination with mode equals 0, and you can see it here. Timeout check is better for hang MySQL Ds, while this command is used in other circumstances. So where would we use this particular command? Well, you know, all these annoying bugs that run into this 600-second timeout for InnoDB, because it starts the InnoDB status monitor and then it runs into some hard-coded 600-second timeout for InnoDB. If you see issues like that, you can set the timeout command here, for example, to 6 or 7 minutes, and you would set mode 3, right? We're looking for a specific text string in the error log, and you set this text string, for example, to InnoDB monitor. Right, like you have a look into one of the error logs, you copy and paste from there InnoDB monitor. So what happens? So the timeout command is prefixed to MySQL D. After 5 or 6 or 7 minutes, MySQL D will be terminated by the timeout command that was given. Then reducer continues and it finds, okay, mode 3, we're looking for a particular text string, and it will go and search the error log, and hey, it will find InnoDB status monitor output, great, which is what it was supposed to find, and it will reduce further on that. If the server terminates before the timeout command, in other words, we haven't run into some sort of timeout or hang or issue or anything like that, then that particular text would not be found, and so that is how reducer can know whether it needs to reduce further or whether it needs to just take another random chunk to throw out of the file. So this is very handy for instance, InnoDB monitor output, some sort of indication in the error log that something is going wrong. There's a deadlock or there's some locking issue, or the monitor is activated and it shouldn't be. Something is going wrong, and that is what we want to reduce on. Now, contrast this with the timeout check mode. So in timeout check, we set a particular timeout, so let's say 600 seconds, and we configure mode 0, which is timeout, right? If you remember here, timeout testing for server hang, shutdown issues, excessive command duration, etc. So we set it to mode is 0, and we set timeout check as 600, and reducer will automatically add 30 seconds, and it will terminate at the given time. It will terminate still using a timeout command, but in this case used very differently. It will terminate at exactly 600 seconds. It will terminate MySQL D, but then it will check if the duration of MySQL D is shorter than the 600 plus 30, but longer than the timeout check. So in other words, the timeout was surpassed and the timeout that was programmed was hit. Why is this so handy? Well, let's say for instance your server is hanging, and there are certain SQL commands that are triggering that. We set this checkout time to 600, we set the mode to 0, and the first round, for some reason, it threw out a chunk that had the triggering SQL statements in it, and it didn't hit the timeout, and the test finished within 3 minutes. So you always want to set this timeout check larger than your normal test case would approximately take, quite a bit larger, right? You want to have a safety margin. So just run it manually with the source command in the MySQL command line. or just run into pQuery, get an idea how long it takes, and then set this maybe 2 times as high or at least a few minutes extra. So the first time it finishes within 3 minutes. So it does the check. Is it larger than the 600? No, it isn't. Okay, so it knows that it's thrown out the statements that cause the hang, and it needs to grab another chunk. So it reduces the chunk size and it grabs a smaller chunk and it throws that out and it runs through. This time the hang occurs. And so it's sitting there, sitting there, sitting there. So remember, there's a timeout, and it's not related to this, but there's a similar timeout that is happening in the back here, and it's set to 600. And after 10 minutes, 600 seconds, bang, MySQL D is thrown out. And now the check kicks in, so it says, okay, is it larger than the timeout check? Yep, it's larger than the timeout check. Is it smaller than the timeout check plus 30 seconds? So, smaller than 630, which, would always be the case because the timeout command would just kill it off straight away. Yes, okay, so I've actually hit my bug here, and I'm going to continue reducing based on this already reduced SQL file. So the 30 seconds is just arbitrary, right? It could have been 5 seconds. I just used 30 seconds as just a pick out of the head number. So you can read a bit more about the 2 different methods here in timeout command and timeout check, and a bit more about the 30 seconds as well. So they're very, very different, and they can be used in very, very different methods. You use timeout command for setting a specific timeout command prefix to MySQL D, which you could use together with mode 2 or 3. You set with a particular text that you want to scan for, maybe even with mode 4, look for any crash, right? Maybe you know that it always results in a crash, although no, that's not so nice. You want to have something to check for specifically, that tells you, hey, I actually run into some sort of timeout issue. InnoDB monitors showing, automatically triggered by the server, something like that. In timeout check, on the other hand, we're using a very hard-coded timeout. If the run is over that time, but under the time plus 30 seconds, then we have hit our hang or whatever it is we're looking for, or maybe a long shutdown, or maybe a slow running query that should complete much faster. So see the power of this, right? You don't have to necessarily look for hangs. You could look for a statement that in certain circumstances runs more than 10 minutes, but in other circumstances, when some prefixed SQL is not there, completes in 2 seconds. So you can do all sorts of funky things with this, and go a lot further than that. Okay, so let's have a look at some skipfee. So we'll go into 4, 5. Here's one of our previous runs. And we'll just have a look at what sort of items we got here. And let's just have a look if we can get this one here. So in this case, what we're going to do is we're going to go here and we'll say skip the verify stage and for sporadic. So I don't really need to put sporadic on, because it gets automatically enabled when I put for skip v on. So when I start running this, you'll see what happens. So for skip v is active, verify stage is skipped, and immediately commencing multi-threaded simplification. And so you remember that we can set that number of threads with the multi-threads option, and so in our case that's set to 10, and it's active, so for sporadic is automatically set active also. So the issue is assumed to be sporadic. And now there's something else very interesting here. Notice this: for sporadic, for skip v, and our pQuery multi is active. And so stage 1 lines, and remember that we looked into that, it's set by default to 90, was overwritten and set to 3 to match. And the reason why it is set to a lower number is because it doesn't ever go into stage 2, right? It always stays into stage 1, and you have to keep this in mind because it doesn't do all the nice little itty-gritty extra reductions for the SQL. It just stays in stage 1, and so it comes up with a number of very short lines, and it comes up with a very short test case, and but not reduced in the greatest detail as to the actual SQL, like the other stages would do. And so why are we setting it to 3? Well, if you think about a test case, and so we've by some point we've thrown out most of the SQL that is not necessary to produce the issue. We've got about 90 lines left, and so it will jump into stage 2 and start to reduce those. But when it jumps into stage 2, it will become single-threaded, and that's not what we want because it's a sporadic issue. So the stage 2 lines is set to 3, and so in other words 3 is very low, right? It will keep going in stage 1 until only 3 lines are left, and by that stage it's easy enough. There might be 4 or 5 lines, it might never get to 3, but by that stage we just want to control C it and grab whatever test case we have and have a look at it and maybe tune it, tweak it a little bit. But in 90% or more of the cases, the test case will be fine just to copy and paste directly into a bug report like that. So I hope that makes a little bit of sense. So basically we're setting it to a smaller number because we want to stay in stage 1, because we want to stay in multi-threaded mode. So here in the background you can see what has been happening, and it's quite happily reducing already. So you can see there at the top 11,284, there just at the bottom, 11,284 lines in the input file. And it's gone through a number of these trials, and we're now down to 2,228 lines, right, in just 1 or 2 minutes. And you can see that it's indeed staying in multi-threaded mode, and each time it's starting 10 threads, and then it says waiting for any forked simplification subproducer. Remember, these are subproducer threads to find a shorter file. It warns you again that it's sporadic and it will take time, which in our case is not true, of course. We're just hacking reducer bit so that it goes faster. And then it terminates those threads, which indicates it has found a shorter issue. And it says, okay, thread 5, so it even tells you which thread reproduced the issue, and it gives you and it saves that as the new shortest test case. And then it will go to the next trial, and straight away it will start up 10 simplification threads again. And you could have set this to 5 threads or to 20 threads or to 50 threads and really floor your machine. That's fine, that works perfectly. So we're down now to 1367, and we could let it go till it's got a few lines left, but I think that it's quite clear what this is doing. Okay, so when we Control C out of it, we get a nice summary, and then we can get that final test case and, if necessary, tweak it a bit more. So you can see why it's interesting to just set it to 3 lines, because we want this stage 1 just to last as long as possible and just clean it out as much as possible. Of course, you could let it go, and then if you knew the issue wasn't sporadic, you could run a true reducer again, so the _out, run a true reducer again, and in this instance we could say no force sporadic and no force skip v. Simply just go through the works, and then it will straight away jump into stage 2 because it's 3 or 4 lines, which is less than 90, and then it will go and nitty-gritty clean out all the SQL. You can see what I mean with nitty-gritty if you scroll a bit down in the script. For instance, it will try and eliminate clauses and things like that, right? It will try and simplify clauses. Okay, so that's an example for force skip v and force sporadic. Now let's have a look at timeout command timeout check. So we'll just have a look at one of them. I had one the other day, which you can see I've been having some fun with. And in this case, we're going to have a look at using a timeout check. So we're not using the timeout command. That one I won't give an example for, but just to give you an idea, here's the timeout check example. So I've set it to 120, so established that more or less this issue will complete easily within the time of 2 minutes. And I've set it to mode 0 as is more or less required to align it with the timeout check. And we're scanning for some bug. Just scroll down a bit here. No, sorry, that's my mistake. We're not looking for any text because we're not using timeout command. We're using timeout check, so we're not looking for any specific text. So the text is just some bug because we're looking for a run to take more than 120 seconds, but less than 150. And based on that, we're going to reduce further. So if I start this reducer, and I'm going to point it to halfway progress of one of the hangs that I was simplifying. This was some issue within upstream MySQL release candidate that was not resolved yet in the release candidate, which I discovered in the pre-release candidate version, but I think that since it has been fixed. Okay, so we're definitely into for skip v and all these modes now, and there's 155 lines, and so looking for trial durations longer than 90 seconds with a trigger at 120. Oh, I must apologize, I slightly got that wrong. It's minus 30, not plus 30, right? So if you set it to 120, it will look for more than 90 seconds, but with a trigger at 120. Yeah, okay, so I slightly mixed that up. It will trigger the timeout at the full setting you've set it to, but it will look for trial durations longer than the 90 seconds, so longer than minus 30 seconds. Sorry for confusing you about that. That's a small mistake that I made there. Okay, so I just want to draw that just so that I get it correct and that nobody's confused. So if you set the option to 120 seconds, then your timeout command is going to be triggered at 120 seconds, but your run duration is needs to be larger than 90, and that is what it's going to verify on. So it's slightly different from what I originally explained. It's been a little while since I looked into that, and I can see here that it's different from what I said. Okay, so coming back to that, let's have a look. In the meantime, we have produced the issue. So 10 threads were started, and it was running, and then let's see how long it took before it terminated. So here we have 37:30 and 39:39, so there's a few seconds for startup. So indeed 2 minutes, that's where the timeout happened, and sure enough thread 1 produced the issue, and so it was running longer than 90 seconds, and the test case was copied, and then it goes and says, okay, great, I got 144 lines left, and now I'm going to work with that new test case and continue to go. So this way you can trigger, you can simplify full MySQL hangs, and in this case the hang is not full in a way that you can still try and connect with the client, and sometimes you get in, sometimes you don't, but at least the MySQL shutdown and whatever wouldn't be working correctly. So that way we are able to see if the server has hung or not Okay, so that's that for timeout command and timeout check. I hope that was slightly clear without my muddle up there. And otherwise, for the next episode, MySQL QA episode 9, we'll be having a look into true multi-threaded test case reduction. So that's very, very powerful. It's world first as far as I know, and I hope you will join me for that one. My name is Roel van der Paar. I work for Percona. God bless.